some more topics. In binomial theorem. So first of all, we have already observed already in the expansion of one plus x to the power n, the coefficients of terms equidistant from the beginning and end are equal. We don't have to go into a proof of it. It is just depends on NCR equal to NC n minus r. That's all. No need to go into a deep formal proof. Then we observe something now. Let us say x plus a whole squared, right? So it is x squared plus 2ax plus a squared, and then x plus a whole cube. Let us say this is x cube plus 3ax squared plus 3a squared x plus a cube. One more observation, there is a way of writing it. Given any polynomial of degree n in one variable x, we normally write it in descending powers of x. Okay, so that is what we have done here. Now what do we observe here? There is a, in each of these there is a greatest term, is it not? In the expansion of x plus a squared, 2 is the greatest coefficient. In the expansion of x plus a whole cube, 3 is the greatest coefficient, although it is repeated once. So our natural question is, which is the, we now come to a next interesting question from the observation question. Find the greatest coefficient find the greatest coefficient in the expansion of x plus a to the power n, x plus a whole raised to n. So we will try to answer it. How can we try to answer it? First, we start with x plus a whole raised to n equal to there is a, you would have observed once again that there is, observe again, there is a lot of advantage when in the theory of equations in algebra, when we rehash or rearrange a polynomial as monic, meaning the greatest power of x will have coefficient 1. Okay, so that is what we have done here. Now let's see how we can answer the question. So the greatest coefficient of x it is sufficient to know the greatest coefficient in this only, in this expansion only. Here when I say this, I am making this comment because a could be some fixed number, right? So it will get multiplied with n times NCR or with NCn minus r. So then it is difficult to pinpoint which is the greatest coefficient. If we were to look at the left hand side expansion, the right hand side arrangement is much better. What do you think? Am I right?
Yes, sir.
Okay, good. Okay, I think your video is frozen. Don't know why.
Mine, sir.
Yeah, your video is frozen. I don't know why.
Wait, even your video just went off.
Oh boy, hold on. Yeah. This is the problem with Skype, Anubhav. I don't know what happens. I just erased the board. You could not take any notes, huh? Could you?
No, sir.
Okay, so I will.
It just went on. Let me just compare the notes, sir. It's not loading, sir.
Okay. How about now? Let me know when it is loaded. Hello?
Yes, sir.
Okay. Let's see if you can see the digital board now. Can you?
Yes, sir.
Okay. So now, as I was saying, this is arranged in a monic fashion, meaning the coefficient of the highest degree of x or the variable is 1. Okay, so so we will continue to find, rather we will find greatest term in this expansion. Now again we observe what is happening to this factor. Observe the factor n plus 1 over r minus 1 decreases as r increases. Because n plus 1 is fixed. Hence the hence the r plus 1th term is not always greater than the. Any question, please stop me and ask me to clarify.
Okay, sir. Nothing yet, though.
Okay, good. Then the rth term, but now comes the deeper observation, but only until tan 6 becomes equal to 1 or less than 1. So, can I erase the board? Hello Anubhav, can I erase the board?
So for me here, so I'm getting good speed.
Yeah, I'm not sure. It could be a software error in Skype. Here I'm having a 45 megabits per second line. You want to see?
Even I'm having about 20.
I'm not sure, Anubhav, what is happening. The line here is better than the one I had fiber optic in Bangalore. Hold on, I will check for our comfort. I might have to blast those guys if the speed is not sufficient. See, you will be able to see. I have still shared the screen with you. That is why I had requested you for that Google Hangout. It normally works fine even when the speeds fluctuate and drop low. Skype is not so efficient in terms of video compression as Google Hangout.
So once it's audio off.
No, it is on. I don't know what is happening. I never switch it off, and when I switch off I tell you. I will. Anubhav, you see the speed 42.29.
Sir?
Do you see my screen?
Sir, your video is loading, sir. Yeah, your videos are now, but the screen isn't shared.
Oh boy, it is already shared. Don't know what's. Is your Skype still being updated?
Not now, sir.
Okay, I will unshare and share again.
So anyway, even here I'm getting about 20.
No, that's why it is strange, the Skype thing.
So I think it was on my end only, sir, because it was updating, it was asking to update Skype.
Now can you see my screen?
Right, it's screen blank right now. I guess it's loading.
Okay.
Yes, I can see 42.2 here. Yeah.
Okay, now
Yes, I can see. One sir. Please scroll down, sir.
sure.
Yes, sir.
Okay, you took notes, huh?
Yes, sir, I did.
Okay. These verbose comments will become soon will clearer in a few more minutes or less than one. So now we go to some simple arithmetic or algebra now. I hope the screen is visible to you.
Yes, sir, it is.
So you have to replicate these steps almost in an actual example. We cannot mug up all this. It's impossible. But the reasoning is easy to understand. If n plus 1 times a over x plus a be an integer, denote it by then if r equal to p, the multiplying factor becomes 1, and the p plus 1th term is equal to the pth. And these are greater than any other term. Further, if n plus 1 times a over x plus a be not an integer, denote its integral part by q. Denote its integral part by q. Then the greatest value of r, then the greatest value of r consistent with 1 is q. Hence the q plus 1th term is the greatest. May I erase the board?
Not so, sir. Yes, sir.
Since we are only concerned with the numerically greatest term, right? The numerically greatest term, meaning without the sign, the approach will be same for x minus a raised to n hence in any numeric example, it is unnecessary to consider the sign of the second term of the binomial.
Once you say your video and screen is going to.
Okay, hold on. The sign of the second term of the binomial. Note in the above we do not need to ratify or memorize the general formula. In each new example, work independently of the general formula. Just follow the approach, that is what I want to say. And this perhaps is a golden rule of maths, not to mug up a formula but just to follow the spirit of the derivative of the proof. So we will apply it. Can I go erase the board?
Yes, sir.
Find the greatest term in the expansion of in the expansion of when x is the value 1/3 denote the rth n r plus 1th term Hence, the greatest value.
One sec, sir. Screen is not shared.
Oh, again it's the black magic of Skype.
Yes, sir.
Now,
Yes, sir.
okay.
Yes, sir.
Fine. This is very interesting. These are some fun problems in the scope of JEE or any basic math. Find the sum of the coefficients, SUM, sum of the coefficients in the expansion of so the identity is solution now in the above put x equal to 1. What will you get, Anubhav? I will drink some water and come. this is a very beautiful, powerful, elementary, whatever you call, fun result in basic binomial theorem and related stuff. If we play with it, if in this expansion of 1 plus x whole to the whole raised to n, call it a, if in a, if we put x equal to minus 1, we get 0 equal to 1 minus nc1 plus nc2 minus nc3, so on so forth. So on so forth, plus minus 1 raised to n, right? NCN.
Yes, sir.
So therefore we get NC1, the sum of odd coefficients is equal to the sum of even coefficients. So on so forth. Okay. What is the time you have? Is it 7:55 or 7:53?
53, sir.
Yeah, okay, thank you. Hold on, I will just, please take notes. Did you take notes?
Yes, sir.
Okay. One nice little question. I think you will like it very much. Find the expansion of so what you can do is call this as a single term y, call this as x. Now this is also binomial theorem. Although we will study this formula when we are tiny tots, this is also binomial theorem. So that's how we find the expansion of this. It is okay, and then add and simplify. Then add and simplify. So now the homework, it's not the whole of the exercise. Exercise 38B, exercise 38B, problems 1 to 7 only. Okay? Okay, we will continue tomorrow. Okay?
Yes, sir.
Okay, goodbye. Thank you.